Hello everyone, my name is Mr. Samali Moses, and going to go through some bit of mathematics right about now. Now, this is the math for senior 3s and the senior 4 students as well. It can be a useful topic for us as far as our mathematics coverage is concerned. Now, I'm going to look through a topic called trigonometry from the introductory part of it. Now, by the end of this, we need to understand the relationship between the sine, the cosine, and then the tangent. So those are the three concepts that we are going to understand and then analyze through as we go through this given topic. Now, what do we mean by trigonometry? Now, when we talk about trigonometry, we are talking about a relationship. We are talking about a relationship between the length of a given side of a triangle. Now, the triangle we are going to look at is basically the right angle triangle. So we are going to look at the relationship between the length, okay, if you have the length and the angles, okay. So we are going to study this and we see how do we use the angles to come up with the length and how do we use the length to come up with the angles. So this is our coverage as we keep on right about now. Now, to begin with a right angle triangle, we say that the right angle triangle, these are triangles whose one of the angles is 90. That's a right angle triangle. So now, if we are to consider a right angle triangle, ABC, so we have A, we have points B, and also we have point C. Now, all these parts here have names. So, and the angle A is called the acute angle. This angle here, A, is the one called the acute angle. So, let's begin by giving these given sides here a name. Now, this part A to C, we call it the hypotenuse. Okay, so this hypotenuse is this longer side. It's usually the longer side edge, the hypotenuse. Now, the part which is the side which is opposite to side BC, or the angle of 90, is what we call the opposite side, and this part SC is what we call the adjacent. Okay, so we need to get to know that in the first place. So we've said SC is our hypotenuse, which is the longer side. Then the side BC is opposite to the angle A. Okay, why are we calling it opposite? Because it is opposite to the angle A. So it becomes, that side becomes the opposite. Then we have this other side. We said AB is adjacent to angle A. So why we are calling it adjacent? Because it's adjacent to this given angle A. So we need first get those names there. We have the hypotenuse, we have the opposite, and also we do have the adjacent. So we are also going to look at the relationship between these three sides that we've looked at: the opposite, the hypotenuse, and then the adjacent. Now we say that the ratio of side BC to side SC is what you call the sine. Okay? The ratio of this BC, let's look at BC, let's look at our part BC, of BC, okay? That's what we are looking at. Of that given BC to the side SC is what we call the sine of angle A. Okay, so possibly let me put it here, draw it here so that we could be able to follow it up clearly. So we say this is our triangle and we're gonna draw it here so we can try to see it clearly. So what we're trying to do, we are generating, so we say this is the hypotenuse, this is point A, this is A, we have A, this is B, sorry, this is B, and also this is C, and the other is the point C. This is our point C, and this is our point B, and this is our point H. So we say this is the hypotenuse, this is the opposite, okay? This is our opposite, and this is our adjacent, okay? So that is what we have first seen in our introduction part. So getting on, we are saying side BC, this is our angle, A, with 8 degrees, and this will be our 90 degrees that we do have there. So we are saying that our sine, okay, our sine is equal to the ratio of BC, okay, the ratio of BC out of SC, okay, BC out of SC, which is this. So this is the same as saying the opposite over the hypotenuse gives us the sine when we substitute through that. Then we are saying also for cosine we abbreviate it as cos. For cosine is the ratio of AB, so we shall have AB, which is this, we shall have our AB out of the SC, okay? SC is our adjacent, SC is our hypotenuse, and then AB is our adjacent. So this will be the same as the adjacent out of the hypotenuse. So this gives us our cos. Okay. Then lastly, what happens when you talk about the tan? So the tan here will be BC, which is the opposite. We shall have BC out of AB, okay, out of the AB, which we will be able to get the BC. Remember, BC is our opposite out of AB, which is the adjacent. Okay, so we need to get to know this relationship so that you see this is how we use them, so that we generate our angles and then the length, as well as we shall be able to see in our coming time. So moving on, so this is what we've said, that when you talk about sine A, cos A, tan A, this is what we do have here. Okay, so as you work out, have that in mind. Sometimes we abbreviate this as if you say, actually, if we have SOH, we have CAH, and we have TOA. Now these ones help us to generate. You may not have to cram them. So in most cases we call it SOHCAHTOA. Okay, SOHCAHTOA. Usually it is one single word as it is in that way. So this helps us. This shows that sine is opposite out of hypotenuse. Then we have cos is adjacent out of hypotenuse. Then tan is opposite over adjacent. So that is how the SOHCAHTOA part comes in from. So in case you forget where to put adjacent over opposite, you try to follow that as well. That is very key to generating that given part. Now if you have any questions at any point, please feel free to type in the comment section. You can type a comment there and we'll be able to give you a response as soon as possible. So how do we put these cos, sine and tan together in the same formula? And that's the relationship that we are looking at. So we're saying that if you consider this right angle triangle, and we have these points R, S, and then we also have C. So we've just renamed this opposite to S, and this will be to R, and this will be to C. We're using the same triangle, and this angle is theta. So how do we generate the connection between the three parts? So we're saying here, look here. So we know that if we talk about the cos, okay, if you have if we are using the RS and C, we say that when you have cos theta, okay, here we know that cos theta, let's look at here. So we say cos theta, let's start with the sine. So we have, if you have sine theta will be, let's do away with this, and then we generate this. So we're saying sine theta is the same as, remember sine is the opposite, okay, which is S, out of the hypotenuse, which is R, okay, which is R. That's what we have generated from that point. Then if you have, and if you want to find S, if for example you would like to find just the point S, okay, so you make S this, making S the subject of the formula, we shall put this out of 1, then cross multiply. So here we shall say our S is equal to R sine theta. Okay, we shall have R sine theta. Do the same thing to the sine, to the cos. So if you have cos theta, so we know that cos is the adjacent is C, out of the hypotenuse, which is R, okay. Then making C, if you need to find point C, which is the adjacent will be, C will be equal to R cos theta when you cross multiply and generate that, okay. So that's what we do have. Then if we now know that we have our tan, and we know that our tan, okay, for the tan, our tan theta is the same as, we know it is the opposite, okay, it is the opposite, our tan is opposite out of the adjacent. But remember, this point S is our opposite, and this point C, we've already got it from sine and then cos, so we do a substitution. So C is our adjacent, okay. So this will be the same as saying the opposite, which is R sine theta, okay, out of our point C, which is the adjacent, which is out of R cos theta, okay. So you will realize that your R, point R, will go off, which is the hypotenuse, which is common between the two. So therefore you realize that you'll find out that when you have that, our tan theta is the same as sine theta out of cos theta, okay. So this is the relationship that we are generating between these two, okay. This is the relationship we are generating between the two. So if you do have your tan theta and you have your sine, and possibly you want to find the cos, you can utilize this given formula to be able to come up with your given solutions that you have, okay. So that is the relationship that we are looking at, that is connecting the sine, cos, and tan together in the same formula, okay. All right, we will do some bit of examples, and then we see how we can be able to generate more and more other things. So the primary formula that we are going to keep using is this given formula here. So we need to have it in mind that if you have tan theta, it is the same as sine theta out of the cos what? The cos theta. So this will help you to come up with your formula, with your other results that you will be needing at any one given time, okay. Let's move on and do some examples. So here we are told that consider a right angle triangle, okay, right angle triangle that we have below with the adjacent, okay. Our adjacent is 3 centimeters, our opposite is 2 centimeters. Let's redraw it here. Let's draw here our triangle, and if you do have any comments, please feel free to use our chat there, and we shall be able to get back to you at any one moment. So we are saying here that here we have 2 centimeters, then here we have 3 centimeters, and we have our ABC. We have points, our points ABC. So here are our points. We have our points here, points A, B, and C. Okay, and here we do have our angle. We have our angle theta here, our angle theta at that given point. So we have a task here, and we are being told, find the tan of theta. Find the tan of theta, sine of theta, and so on and so forth. Okay, so how do we get our tan theta? Okay, tan theta. So we know that before you even write down, before you go direct and do a substitution, this is our guideline here. So we know that our tan is equal to the opposite out of the adjacent. Okay, our opposite out of the adjacent. So what do we do in such a case? We do a substitution. So our tan theta will be the opposite. Please don't mix up the sides. We know that this is our hypotenuse, this is the opposite, and this is our adjacent. Okay, so here what shall we get? We shall be, our opposite is 2 out of the adjacent, which is 3. And that is our answer at that given point. You can divide through, and you can say that 2, possibly you divide it by the 3, and then you get your decimal point there. It will also be fine as well. So you may use either way, or you may leave your answer in that given formula. It will be fine as well, which is 0.666, and so on and so forth. Then we also been told to find sine theta. We also been told to find sine theta. Okay, sine theta. So we know that sine theta, we go back to this, is our opposite, okay, out of the hypotenuse. Okay, so we move on. What is our opposite? Our opposite is 2. So which is 2. Our hypotenuse is unknown, which is h. We will keep it as h, which is h. But how do we find our opposite when we have the adjacent and the opposite? If we remember our Pythagoras theorem, okay, we use the Pythagoras theorem. So we have here our sine theta being equal to 2 out of h. So how do we get that? We say from Pythagoras theorem, h squared is equal to the opposite squared plus the adjacent squared. Okay, the longer side is the h, the longer side. So we know the opposite already. So this will be 2 squared plus 3 squared, which is equal to h squared. So our h will be equal to the roots. Okay, 2 squared will be 4 plus 9 squared, which is 9. Okay, so this will give us the root of 13. Okay, the root of 13. So this will be your point h. That's how you get your, you can simplify it further. You can simplify it further as well, but you may leave it like that for better way of solving it. But if you decide to do that, you can say the root of 13, which will give you 3.6. That will be your hypotenuse. Okay, so we go back and do a substitution, which is we have our sine theta being equal to 2 out of 3.6. Okay, 2 out of 3.6. So this will be 2 divided by 3.6. Please, when you work out mathematics, ensure that you have a calculator close to you for easier working out of your work. Okay. And also take note of the decimal places they have told you. Sometimes it can be 2 decimal places, 3 decimal places, 1 decimal place. So ensure you keep that. But if you've not been told, then you can use 1, you can use 2, 3. It is all good as well. Moving on, we're also told to find our cos theta. So we know that cos is the adjacent over the hypotenuse. And from our triangle that we have, our adjacent is 3. If so, our adjacent is 3. Okay, our adjacent here will be 3. So we shall have 3 out of 3.6. Okay, this will be your cos theta. So 3 divided by 3.6 will give you 0.83. So this will be your cos theta. Okay. So in so doing, you realize that you can easily and quickly work out your work as long as you get to know what is cos, what is tan, what is sine as well in so doing. Moving on, let's do some other example. Please, we are utilizing the cos and then the sine. That's what we are utilizing to ensure that we come up with the right responses to our questions. All right. So we have our next example 2. So we've been told find the length indicated as in the figure below. Okay, so we do have a length to find out. So please take note of that we first need to identify our sides. Okay, identify your sides so that you can be able to get to know what you're going to work through. So we know that this is our opposite, this is our adjacent, and this is our hypotenuse. Okay, and that's our hypotenuse. So the sides that we have our opposite, we have our hypotenuse, we have our adjacent. Now when you look through these points here, try to look out. If you don't know the values, if you don't know some unknowns, if you don't know some given length of certain sizes, of certain sides, please use, you can easily find them out using the tool. Like for example, if you have the opposite and adjacent, you can use them to find the hypotenuse. Okay, so here, because we do not have the adjacent and we don't have even the hypotenuse, meaning whatever we are going to use, the cos, we have, remember our cos, our sine, and our tan. So we said our tan is adjacent over hypotenuse. Our sine is opposite hypotenuse, and our tan is opposite adjacent. So look at the two trends, and you look at the 3, and you know that I can use this or I can use the other. So look at this. So in here, I can be able to use the tan. Okay? Because all this, the sine and the cos require you to find the hypotenuse. And to find the hypotenuse, you must also be having at least the adjacent. So you realize that you best need this tan to be able to come up with your result. So, and we are using the tan, and we have our angle at 35. So we go and write down our expression. So here we shall have our tan theta. We know that tan theta is equal to, we have the opposite over the adjacent. Okay? opposite over the adjacent. So we have our theta, okay? We have our theta, and we shall have the tan of theta is 35 degrees is equal to the opposite, which is 4, out of the adjacent, which is x. Okay? So cross multiply. So our 4 will be equal to x tan 35. So to remain with x alone here, we divide. To remain with the x here, we shall be able to divide through by, tan 35. So 4 will be equal to, 4 out of tan 35 will be equal to our point x. So when you find x will be 4 out of tan what? 4 out of tan 35. Now to solve this, get to your calculator. Okay? When you get to your calculator, press tan. Okay? Press tan 35. Okay? Press tan 35. And tan 35 will be 0.47 and some other, but we can take to 2 decimal places. Okay? So then after that, we shall say, after that, we shall now divide through by 4. So it will now be 4 divided by 0.47, which will be able to give us 8.5. And this will be your x. Okay? And that will be your x. So that is how you are going to come up with your result. So as we keep working through, keep getting more other numbers, but make sure that you know that when you have your tan, you know what to use it for. When you have your sine, when you have your cos, you can easily manipulate through to come up with your result. All right, let's try maybe one more example. Let's try out one more example, then we will be able to close this session. Now, moving on, we have our third example here. We have our third example shown here that we are going to work through together. Here we are. So find the value of x and y. Find the value of x and y in the figure. Correct them to 2 significant figures. Okay? So, same thing. Okay? We have our same thing here that we need to work through. So you first redraw your triangle here. Actually, what you're going to do, you're going to redraw your triangle to find out which one is the, so you can, when you redraw your triangle, maybe to be able to find out that this is the opposite, this is the adjacent, and so on and so forth. So here we shall have our angle here. So this will be our y. Okay, this will be our y, and this will be our point x. Okay, this will be our point x here, and this will be our 8 centimeters when you redraw it that way. And then finally we will be having can have our 33.2 degrees over there. So when we redraw it, you can easily now know which one is the opposite, which one is the adjacent, and then which one is the hypotenuse. So we go and still use the same method. Please keep the other method with you. Keep the method, the other method of tan, cos with you. Don't leave it out. Okay? It's very, very helpful when you're working out your numbers. So finally, I said we're doing this, and So we know that we do have, when we draw our triangle here, possibly we can be able to see it clearly. So this is our triangle, our right angled triangle that we do have. And please do not change anything, don't change anything. So we have here our 33.2, we have our y, we have our x, and we have our 8 centimeters over here. Okay, so our role is to find x and y. X and y. So right now we have the hypotenuse given. The hypotenuse has been given, but our opposite and the adjacent is not. So we are going to make use of the hypotenuse. So what does this mean? It means that we can use either the cos or we can use the sine to be able to come up with that. Let's start with the, let's use the sine. So we can say sine theta is the opposite over the hypotenuse. So we shall have our sine, our theta is 33.2, which is equal to the opposite, which is x, out of the hypotenuse, which is 8. Okay, so when you cross multiply, okay, when you cross multiply, your x will be equal to 8 times, okay, 8 times sine 33.2. Okay, that's how you'll get your x. So we do get your calculator still. Go to your calculator. You put in sine 33.2. It will give you 0.9. Then multiply your answer. Okay, multiply your answer by 8. And you'll be able to come up with 7.81. Okay, this will be your point x. And these are centimeters that we have. Please don't forget the units. Don't forget the units. Put your units to ensure that your work is quite well organized through. So moving on, now that we know our x, okay, we know our opposite, we have our hypotenuse, we can use the Pythagoras theorem. Okay, so from Pythagoras, okay, from the Pythagoras theorem, okay, please have the theorem with you. So we have the h squared, which is the hypotenuse, is opposite squared plus the adjacent squared. So this is 8. We already know this is 8 squared, which is equal to the opposite, which is 7.18 squared, plus our adjacent, which we do not know, as y squared. So when you bring these collect-like terms, you shall have 8 squared minus 7.18 squared being equal to y squared. So when you get 8 squared minus 8 squared minus 7.18 squared, we shall get 56. Okay, we shall get actually we shall come up with 12. This will be 12.44, okay, which is equal to y squared. Get the root of this. Okay, so meaning our y will be equal to, when we get the roots, we get the roots of 12 point, we shall get the root of 12.44, and this y will be equal to 3.52. Okay, so that will be your given point y. So we can try to keep on working through with our different methods as we try to gauge through, ensure that you make use of that formulas of the tan, okay, the cos, and then the sine as well. So when you work out with this, it becomes quite easy. There are quite more other numbers that you'll keep on working through, and if you're following us, please, I've given up I've given you this number. I think you can be able to see it, that you can try out on your own. So you'll have to use this. I have this example, and I also have that example and that as well. So try to work it out, send through the Google Classroom, and I'll be able to check through. Otherwise, thank you so much for listening, and please don't forget to subscribe to the channel. Keep checking through the videos, the different lessons from different subjects, and we'll be glad to hear from you. Thank you so much, and may God bless you.